Okay, so I just thought I'd do a quick repair video on this Technika X2214C 22-inch HD LCD television. It's a pretty common TV sold by Tesco's under the Technika brand. And these come in, I think, black, white, pink and silver colour. But it's the 22-inch LCD that uses a Samsung panel. This particular one being an LJ96 03802W panel, or an LTM220M1. It's a very common issue with these particular panels, and I've encountered it 4 times this year, and last year I think about 4 times as well. And it's quite a difficult repair. However, I found a new method of bypassing the failure and keeping the TV working. So the fault is the TV will turn on, you'll get backlights for a second or two, and then they'll shut down. So customers describe this as the screen flashes. So the screen will come on, and then a few seconds later it will shut down. However, the rest of the TV will stay on and you'll still get sound, and if you shine a torch on the screen you can actually see the LCD glass working. What's happening here is the backlight is failing. It's a really common issue on these particular TVs. I've seen it on bag caps, I've seen it in person quite a few times. And the fault is with the backlights at the top of the screen here. And in particular, the CCFL bulb that has the red and white connector. It's always, in my experience, the red and white connector bulb that fails. And what actually happens is the bulb cracks and it will need to be replaced. And what actually happens is when it cracks, the bulb can no longer light. And what happens is this inverter detects that a bulb isn't present or isn't working, and it will shut down the entire backlight. So there's 4 bulbs in total, and there's 2 on the bottom of the screen and 2 at the top. And what happens is it's always this red and white one that fails, and that one bulb failing can cause the whole backlight system not to work. And I think it's actually a bit of a design flaw with this particular panel, because I don't know whether the panel was either clamped too hardly or too closely together, or if the lamp wasn't seated properly or something. I don't know, but I've seen it several times, and it's definitely a common issue on these panels. And you can replace the lamp if you want, and I've done that on all the other ones that I've repaired. However, that is a really long process. It takes about 3 hours, because you have to take apart the whole LCD panel module, which consists of the frame, the LCD glass, the plastic bezel that holds the diffusion layers on, the diffusion layers, and on this one it uses an optic to diffuse the light from the bulbs at the bottom and the top to the center of the screen. And then you have to take apart a bit of metal here which has some aluminium on it, so it's really difficult to do. To gain access to the bulbs and then actually replacing them is twice as hard because you have to solder very little wires and then push it up into a little rubber grommet here, and it's really hard to do without cracking the new bulb or breaking off the wire that you soldered. And I've done it, and I've cussed quite a few times when fixing these in the past, but today I just decided to do a new method. Rather than replacing the lamp, I decided to see what the screen would look like without the top lamp present. So what I did was, I figured out that the red and white lamp was again at fault. So I unplugged it, and I have a spare set of 22-inch CFLs, which were pulled out of a smash screen TV. What I did was I hooked one of these up, and these are both good lamps. I hooked one of them up and left the original good lamp in place, the blue and grey. And I looked at the screen to see how much difference having one lamp out of two working at the top, and to be honest, the difference in the brightness is, you have to look pretty hard to be able to notice it. You know, it's barely noticeable at all, so I thought, instead of bothering to take this entire panel apart and change over one of the lamps and faff with all that, it just takes ages to do, and there's a lot of screws and there's a lot of little parts that could get damaged. I just thought, why don't I modify this inverter? Now this inverter, which is on this TV, is an LEKE, model LK-IN220417A inverter. This inverter has a protection circuit built into it. Now, if you know anything about protection circuits and on inverters like this, and on normal LCD inverters in general, you'll know that, well, on this particular inverter, the protection circuit is for every lamp. So, whereas on a bigger inverter, say a 32-inch, the protection circuit will be per every 2 bulbs or so, from what I found. Anyway, but on this control IC here, which I think is a OB3, here we go, it's a OB3302CP IC. This IC is the protection IC, and what it does is it creates the VCC voltage for this MOSFET, which drives the square waveform for the transformers. Now, if this detects, this also takes the return line, and the return line on these in these lamp connectors is normally the grey and the white wire, so it's the return voltage coming from the lamp. It takes that return voltage and it monitors it, and say if there's a change in the current, which i.e. a lamp being not present, it will engage the protection circuit and it won't run the MOSFET. It cancels out the VCC voltage which drives this MOSFET. Now, there's a section to this, and this has been a bit of a pain to show you. There's a section up here which takes the return voltage, switches it for this control IC, and if it detects that there's a fault, there's a diode here which breaks over and cancels out the VCC. And what I did is I made a little diagram here. WBL means working backlight, and BLPO means backlight protection operational, or backlight protection on, or something, I don't know. But I just took the voltage regions because I hadn't got the schematic for this, and Budum on Badcapsnet linked the schematic after I'd done this, but I found that the VCC voltage is 2.2 volts when it's working, and the return voltage is 1.9 volts. Now, when the protection circuit is on, the 1.9 volts disappears because these transistors have clamped, and that diode is no longer sending the return voltage. So that means the protection circuit is on, so it won't send the VCC voltage to the MOSFET to drive it. So I found that the protection circuit voltage actually gets clamped and then sent through a little capacitor marked as C6. Now that capacitor, which was there, you can see that I've desoldered it. If I remove that, the protection circuit gets overrided and it is no longer engaged. So after removing that little capacitor, I can now run the TV with the top lamp not being present. You know, if I wanted to replace the lamp and that cap is still not present, I could, you know, I could do that and a new lamp would work. However, it allows me to run it without the top lamp connected. Now, as this lamp is faulty, I would recommend that you do not plug it in, because it could arc over to the chassis, which would be bad. So, initially I thought that this capacitor was the for the protection circuit, because when the protection circuit was on, the voltage going from that wasn't present, but that was something else. I haven't even looked at the data sheet for this IC yet, but sort of figured it out. So C6 is no longer present on this little inverter, and that means the protection circuit is no longer present. So when I plug it in, I can show you this working. Didn't take me long to find it either, about 10 minutes. There we go. Okay, so should they're in standby. Takes a few seconds. There you go. As you can see, backlight is up. DVD drive initializers, and the backlight is not shutting down, even with only one lamp at the top present. That's because I've turned the feedback circuit off that goes to the IC. And the image looks normal. But seriously, you can't tell there's a lamp missing. I have another one of these TVs, the exact same TV, which I've had to perform the exact same repair, but I actually replaced the lamp on the top, that I can contrast the image quality with to show you that it doesn't really even affect the image quality with one lamp missing. But yeah, what I might do is just adjust the brightness, so it's put it on full brightness, so the screen is you know, you're not going to be able to see any dark patches. But pretty common on these little TVs. Hopefully that's a easy, cheap fix. Well, it doesn't even cost anything to desolder that cap. But yeah, what I'm going to do is put that inverter back in and show you the image quality. And replace the output caps on the power supplies. They're prone to failing on these TVs. Reassembled the inverter and replaced its capacitor. They were caps on caps. They're now Rubicon, Jamicon, and I think Panasonic on the inverter. So, it's at full brightness. You can see that that is slightly brighter than the bottom. I doubt it will be noticeable during use. I mean, you know, the image like there is still perfectly viewable. What I could do is unplug one of the bottom bulbs. In fact, you know what? I'm going to try that and just see what happens. Might be difficult to do. Just see what happens, just see if it makes any difference. I'm driving them at full voltage as well, or full brightness. Takes time to turn on. Backlight on. Oh. Oh no, it is on. It's pretty dim now. There's a bit of a weird light spot over there. Yeah, okay. Maybe I can't run it with just the top and the bottom one disconnected even. Try again. I'm doing this on video and I'm not going to bother cutting this out, it's just to show you what would happen. Yeah, now it looks normal. Yeah. Alright. It's a bit dimmer at the top, but you know, that doesn't really, it doesn't really look any different. So, I'm going to reassemble this and test it.